Greetings and welcome to week 4 of geometry. So this week we are continuing to look at quadrilaterals, and we're going to add some more special types of quadrilaterals to our list that we've already learned so far. So let's start with a warm-up problem. I do want to make sure that at this time that you do have your math notebook out and you're ready to take good notes. I'm going to start with a warm-up just like every week, and I should see the warm-up in your math notebook. Remember, you do need to take notes as you watch this recording, and you will submit those and get credit for that at the end of the week. So for our warm-up this week, we are going to decide if something occurs always, sometimes, or never. And we're going to respond always, sometimes, or never to these two questions below. So first, a square is a rhombus. Does that always occur? Does that sometimes occur? Or does that never occur? And then the second question you're going to respond to is a parallelogram has 4 congruent angles. Is that sometimes, always, or never? And I have this chart, this little flow chart to the right that we looked at last week that you can use to help answer this question. Or these two questions, I should say. So go ahead and click pause and respond to these two questions with sometimes, always, or never. And then when you're ready to check your work with mine, go ahead and click play. All right, so the first prompt was a square is a rhombus. A square is a rhombus. So remember how this flow chart works is that a parallelogram is our most basic type of quadrilateral we've learned about so far. And then we learned special types of parallelograms. So a rectangle is a parallelogram. It's got all the characteristics of parallelograms, plus it has some additional characteristics that makes it a rectangle. Same with the rhombus. It is a type of parallelogram, and then it has some additional characteristics that makes it different or makes it a rhombus. So a rhombus is a type of parallelogram, a rectangle is a type of parallelogram. Then we get to square. So a square has all the characteristics of all these quadrilaterals and then some. So a square is a rhombus. Well, that is true all the time. So that's going to be always. So a square has all the characteristics of a rhombus. It has all the characteristics of a parallelogram. And then it has some additional characteristics that makes it more specifically a square. So a square is always going to be considered a rhombus because it has all the characteristics of a rhombus. Then we have a parallelogram has 4 congruent angles. Well, which quadrilateral does have 4 congruent angles? Well, a rectangle has 4 congruent angles. All of them are right angles, as well as squares have all of their angles are right angles, so they are all congruent. A rhombus does not have 4 congruent angles. So a parallelogram only sometimes will have 4 congruent angles. Rectangles and squares do, and they're a type of parallelograms, but rhombuses do not. So that means sometimes a parallelogram will have 4 congruent angles. All right, I'm going to go on to the next slide, so if you need more time, click pause. All right, so what are we doing this week? This week we are wrapping up Unit 5, really. So we are going to jump in our last session and learn about the last 2 types of quadrilaterals from Unit 5. Kites and trapezoids. So in Unit 5, Session 8, you're going to learn the properties of kites and trapezoids. And then we've learned about every type of quadrilateral that we are going to from Unit 5. So then, after you complete Unit 5, Session 8, you're going to complete a quadrilateral project. So in this quadrilateral project, each of you are going to be assigned 4 vertices. You're all going to be assigned 4 different vertices. So the vertices that your classmate might get are going to be different than the vertices you get. And you are going to take those vertices, you're going to plot them on a coordinate plane, and then you're going to determine what type of quadrilateral you have. And how you're going to do that is you're going to calculate the slope of your vertices, see if you have any parallel sides. Maybe you can look at the slopes and determine if you've got some perpendicular sides to determine some of the angles of your quadrilateral. Then you can use the distance formula to examine the diagonals, and then you'll look at all the properties of all the quadrilaterals you've learned about and determine what type of quadrilateral you have. And then just a heads up that Unit 5 test is coming up next week. So let's go back here. So since the Unit 5 test is coming next week, I just want to put that into a warning for you guys, or not really a warning, just let you know it's coming up, so that you can be working on any missing work if you have any, and also redoing any Unit 5 assignments. Remember, that is a great way to study for the Unit 5 test. And remember also that when we complete Unit 5, you can no longer do redos from Unit 5. So just a heads up that we are wrapping up the Unit 5 assignments, taking the test next week, which means next week will be the last week to redo assignments from Unit 5. All right, so are you ready for a new quadrilateral to add to our list of quadrilaterals? All right, the next quadrilateral we're going to learn about is trapezoids. So a trapezoid is a quadrilateral. It's got 4 sides, but it's defined as a quadrilateral with only one pair of opposite sides that are parallel. So only one side, one set of opposite sides that are parallel. So is a trapezoid a type of parallelogram? Remember, parallelograms have 2 sets of opposite sides that are parallel. So a trapezoid is not a type of parallelogram. It is not a type of parallelogram. Remember, parallelograms have 2 sets of opposite sides that are parallel, where a trapezoid only has 1 set of opposite sides that are parallel. And those are our bases right here. So that is what makes something a trapezoid, is you have 1 set of opposite sides that are parallel. Now, a more specific type of trapezoid is called an isosceles trapezoid. And we've already seen this term before, haven't we? Isosceles. We talked about isosceles when we had isosceles triangles. An isosceles triangle was a triangle that has 2 sets of, or 1 set of, 2 congruent sides. Start over there again. An isosceles triangle had 2 congruent sides. Well, an isosceles trapezoid is a trapezoid that has congruent legs. So it has 2 congruent legs. So a isosceles triangle is different than just a plain old trapezoid because it has to have 2 legs that are congruent, where a normal trapezoid does not have to have any legs that are congruent, where an isosceles trapezoid is going to have a set of congruent legs. So remember, that tick right here lets us know that this leg and this leg are congruent. This arrow and this arrow lets us know that these 2 sides are parallel. So it's got a set of parallel legs, which makes it a trapezoid, and then more specifically, it has a set of legs that are congruent, which makes it more specific, a isosceles trapezoid. So we're going to go to the next slide, where we're going to work on a practice problem and put to use some of the properties we've just learned. So if you need more time here, click pause. Remember, taking notes, drawing pictures, you should include pictures in your notes. Don't just copy down the words that explain what a trapezoid is or what an isosceles trapezoid is. Draw a picture. Pictures help us really see and understand more of what the terms mean. All right. We've talked about the sides of trapezoids, but now let's talk about the angles of trapezoids. So if a trapezoid is isosceles, And this trapezoid is an isosceles. How do I know that? Well, there's a tick here and a tick here, which lets me know that these two sides are congruent. So if we have an isosceles trapezoid, then each pair of base angles, so remember this is a base and this side is our base, each side of base angles will be congruent. So that means that angle A and angle B will be congruent. And then that means that angle D and angle C will be congruent. So notice there's one arc here and one arc here, meaning A and B, those two angles are congruent. Then I did two arcs and two arcs here, showing us that angle C and angle D are congruent. These two angles are congruent. Then if we were to add some of our adjacent angles, if we were to take the measure of angle A and add it to the measure of angle D, they're going to be supplementary. Remember, that means they're going to add up to 180 degrees. And then if we add our other two sets of angles that are remaining, angle B, the measurement of angle B plus the measurement of angle C, if we add those two up, we will also have a total of 180 degrees. Those two adjacent angles are supplementary. All right, so I'm going to go on to the next slide where we're going to put to use some of these properties to solve some problems. All right, so I've got a trapezoid. I know that because I've got two sets of two sides that are parallel. And then I've got another property here. Well, I've got a tick on this leg and a tick on this leg that lets me know that these two legs are congruent. Therefore, I'm dealing with an isosceles trapezoid. I've got an isosceles trapezoid, which we learned some properties about on the previous side, or the previous slide. I'm also given some information here. I'm given that angle S is 50 degrees. I'm given some information about this isosceles trapezoid. I have one of my angles is 50 degrees, and then I'm given the length of side RQ as 2.16. And then since I know RQ is 2.16, I know that SP would also have to be 2.16. So I'm just going to write that information in. And then I'm going to come back over here and look what the problem wants me to find. It wants me to find the measurement of angle P. So let me change colors here. So we want to find the measurement of angle P. We'll do that in orange. And then we want to find the measurement of all the other angles, R and Q. Q and R. So how can we find all these missing angle measurements when we're only given this angle measurement right here, angle S? Well, because I'm also given two side lengths, it allows me to determine that this is in fact an isosceles trapezoid. And once we know this is an isosceles trapezoid, we can use the properties that we just learned on the previous slide about the angle measurements of an isosceles trapezoid and the patterns that occur. So right away, can I find the measurement of angle R? So angle R is right here. Can I find that angle measurement? Well, sure I can. Remember, we learned that the base angles will be congruent. So I learned on the previous side that the measurement of angle S has to be congruent to the measurement of angle R. Well, I know the measurement of angle S. It's 50 degrees. So if I know the angle measurement of angle S, don't I know the angle measurement of angle R? It would also have to be 50 degrees. So the measurement of angle R has to also be 50 degrees. So we found one of the unknowns. What about angle P? Well, what do we know about the relationship between angle S and angle P? They're adjacent angles, so they have to be supplementary. So supplementary means adds up to 180. So I know that if I take the measurement of angle S and add it to the measurement of angle P, it has to give me a total of 180 degrees. Well, now I could substitute in that 50 degrees that we were given for the angle measurement of angle S. We don't know the measurement of angle P, and we set it equal to 180. Now we've just got a basic algebraic equation, And to find the measurement angle P, we're just going to subtract 50 from both sides. And I get the measurement of angle P equals 180 minus 50 is 130. So the measurement of angle P is going to be 130 degrees. So now, do you know what the measurement of angle Q is? If we know the measurement of angle P? Sure we do. The measurement of angle Q also has to be 130 degrees. Our base angles are always going to be congruent, so that means that the measurement of angle Q also is going to be 130 degrees. So we found all three of our missing angles using the properties that we learned on the previous slide about isosceles trapezoids. So I'm going to go on to the next slide, so if you need more time, go ahead and click pause. We're going to look at some more problems. Or actually, no, we're going to look at the diagonals of trapezoids next. We're going to look at the property of diagonals next. All right, so remember, a diagonal is when we start at one vertex and draw a straight line to the opposite vertex. That is a diagonal. So in an isosceles trapezoid, we've got a tick here and a tick here, which lets us know we've got a set of congruent sides, making this a isosceles trapezoid. In an isosceles trapezoid, the diagonals are going to be congruent. The diagonals are going to be congruent. So I just went ahead and added the points or the vertices of this trapezoid, vertices A, B, C, D. So this makes this trapezoid A, B, C, D. If we are looking at the diagonals, this quadrilateral will be a isosceles trapezoid if and only if our diagonals are congruent. So AC, the distance from AC would have to be congruent to the distance from B to D. And that, if we have that true, then we know that we're dealing with an isosceles triangle. An isosceles, or triangle, I meant trapezoid, not triangle. We're dealing trapezoids now, not triangles. So if we have opposite, or our diagonals are congruent, then we know we're dealing with an isosceles trapezoid. We're dealing with an isosceles trapezoid. So remember, if we're given the vertices and we want to find the distance from A to C, we would use the distance formula. So just a hint when you go to do your Unit 5 project this week. So let's now look at number 1. Let's look at this first example here, using diagonals. So if we are we know we've got a four-sided figure here. Then we've got one set of opposite sides that are parallel. So that means we're dealing with a trapezoid, not a parallelogram. And then we've got this tick here and this tick here that lets us know we've got one set of opposite sides that are congruent. So more specifically, we know that this quadrilateral is an isosceles trapezoid. Then we're given some information. We are given that JN, so the distance from J to N, is 10.6. I'm going to put that in there. And we know NL is 14.8. So what is the entire length? Do we know the entire length of that segment, JL? Sure we do. JL would have to equal, we just add together the two given values that we were given, and what do we get? 25.4. So now we're asked to find the length from K to N. We're asked to find the other length of the other diagonal. Well, since we know that this is an isosceles trapezoid, we know something about our diagonals, don't we? That we just learned. We know that JL has to be equal to KM, right? Well, since we now know that JL is 25.4, that means KM must also be 25.4. So KM is going to be 25.4. And we were able to determine that by now knowing that the diagonals are going to be congruent. I'm going to skip number 2. I'm running out of time here. I do want to introduce kites. So you're going to learn some more about trapezoids. You're going to learn about the mid-segment theorem. So if we draw a segment in a trapezoid, that's called a mid-segment, and you're going to learn a little bit about that on your own in the Schoology lessons this week. But I did want to introduce the last type of quadrilateral that you're going to be learning about, and that is a kite. So what does a kite look like? It looks like those kites that we fly up in the air. But it's got some properties about it that make it special, that make it a kite. So with a kite, we're gonna have two pair of adjacent angles that are, or adjacent sides that are equal. So here we've got adjacent sides, those are equal. These two set of adjacent sides are equal. So if you have two sets or two pairs of adjacent sides that are equal, you're dealing with a kite. The angles are going to be equal where the sides meet. So that means this angle here and this angle here are going to be equal. So our non-vertex angles are equal. This angle here and this angle here are only two sets of congruent angles. This angle and this angle, they are not congruent. So we only have one set, and that's where our two unequal sides, our two sides that are not the same, that are unequal, where that vertex meets those sides, those are the two angles that are going to be equal. Your diagonals are going to meet at a right angle. So the diagonals will all meet at a right angle. So there's going to be right angles in every single one of those vertexes. The diagonals bisect each other. So we've got this diagonal bisects this one. It's going to cut it into two equal segments, and then the diagonals bisect the angles. So that means this angle here is going to be equal to this angle. Do it like two of them, and then these two angles down here would be congruent to one another. So I know I quickly went through those properties. You will see those properties reintroduced to you in your Schoology lessons, but I did just want to go over those really quick. Again, we don't have two sets of opposite sides that are parallel, so kites are not a type of parallelogram. They are a type of quadrilateral. And are we ready for the last slide? The key phrase assignment. So we don't have enough time to go through we didn't have enough time to go through any of the kite examples, but again, lots of great information in your lessons this week. All right, so our key phrase assignment question. You need to answer this question to get your points for watching the recording. You learned what makes a trapezoid different from a parallelogram by watching this recording. So I want you to tell me, how is a trapezoid different from a parallelogram? That is it. Remember, I'm here for help, and the only way I know what questions you have is if you are actively reaching out and asking me those questions. So please, if you have questions this week, send me a quick email. Let me know what your question is. Otherwise, have a fantastic rest of your week.